Let's take a look at the counting principle. If Anthony is painting 2 walls in his house, one in a shade of green and the other in a shade of blue, there are 3 shades of green to choose from and 2 shades of blue to choose from. How many combinations of colors are possible if you must choose 1 green and 1 blue shade? Okay, so there's a long way to do this problem, and then I'm also going to show you the shortcut. Now, the way to figure this out, if you didn't know the shortcut, is to list out all the possibilities. So if there's 3 shades of green to choose from, let's call those 3 green shades A, B, and C, right? Color A, color B, and color C, which are all shades of green. There's also 2 shades of blue he can choose from, and let's call those shades of blue colors D and E. So if I look at these lists and I try to make myself an ordered list of all the possible combinations, well, he can choose green color A and blue color D, green color A and blue color E, right? Those are all the combinations picking green color A. And then you would keep going. He could also choose green color blue with either of those, right? With blue color D, or green color blue with blue color E. Or the final set is if he chooses the sea green color, he could have that with the blue D, or he can have that with the blue color E, right? And that's it. That's all the possible ways you can combine those 3 colors of green with those 2 colors of blue. So there's 1, 2, 3, 4, 5, 6 possibilities. Now in this case, writing out the list wasn't too bad because there were only 3 possibilities for one and 2 possibilities for the other. But let's say there were 100 possibilities for each. That would be a really long list that we probably don't want to write out, which is why it's really nice to have a shortcut. And our shortcut is the counting principle. The counting principle tells us if there are n possible ways of doing one thing and m possible ways of doing another, we can multiply those 2 things together and say n times m represents the total possible combinations. So if we look at that here, there's 3 ways of picking a green color, right? There's 3 different greens to choose from. So we could say that n is 3. Times or multiplied by, well, there's 2 different blue colors or 2 different ways to pick your blue. So 3 times 2 tells us that there's 6 possibilities or 6 combinations. Now notice that's the exact same answer we got when we wrote out our list. The list just shows us what those possibilities are, and the counting principle tells us how many ways. If Kevin is painting 2 walls in his house, one in a shade of green and the other in a shade of blue, there are 2 shades of green to choose from and 4 shades of blue to choose from. How many combinations of colors are possible? Okay, so this time we have 2 shades of green and 4 shades of blue. So if I use my counting principle and say, okay, n is 2 possible ways to choose my green color, and m shows me 4 possible ways to choose my blue color, I can simply multiply those together, right? The counting principle was n times m. So in this case, I would say 2 times 4, and that tells me that there's 8 different ways for him to combine those colors. If there are 5 different color tulips and 5 different color roses, how many combinations can you make with 1 tulip and 1 rose? Okay, well again, using our counting principle, there's 5 different ways to pick a tulip and 5 different ways to choose a rose. So we can use that as n and m. Remember, our rule tells us to multiply them together, n times m, which in this case would be 5 times 5. Okay, and if I multiply that out, 5 times 5 means there's 25 different ways to combine the roses and tulips. In gym class, there are 2 different boys and 5 different girls. If you want to pick a male and a female team captain, how many different combinations can you choose for team captains? Okay, well, there's 2 different boys and 5 different girls. Remember, our counting principle tells us if we multiply these together, that's going to tell us how many different ways we combine those two things. So 2 times 5, if we multiply that out, tells us there's 10 different ways for us to choose team captains. There are 4 types of hairstyles and 3 types of veils. You must choose a pair of them. How many different combinations of the two are possible? Okay, well, our counting principle tells us to just multiply these together, right? 4 different hairstyles times 3 different types of veils. 4 times 3 gives us 12, so there's 12 different combinations of hairstyles and veils. You and your friends have enough time to play one of your 4 card games. One of your 2 tabletop games. How many different combinations of games are possible? Okay, well, don't let the you and one of your friends mess you up. The combinations we're talking about, we have 4 card games and 2 tabletop games. So if we're finding the combination of games, we're going to multiply that together. 4 times 2 means there's 8 different game combinations that you could choose to play. There are 3 different types of clownfish and 4 types of suckerfish. If Jayden only has room in his fish tank for 2 fish, how many different combinations of fish are possible if one of each are chosen? Okay, well, he has 3 different things he can choose for the clownfish and 4 different types he could choose for the suckerfish. And he's choosing one of each, so we want to see how many combinations we can make of those 2 types of fish. Well, there's 3 possibilities for clownfish and 4 for suckerfish, so we're going to multiply that together, and there's 12 different combinations he can make of those 2 types of fish. If Ava is painting 2 walls in her house, one in a shade of green and the other in a shade of blue, there's 4 shades of green to choose from and 2 shades of blue to choose from. How many combination of colors are possible if she's choosing 1 shade of green and 1 shade of blue? Okay, well, our counting principle tells us to multiply the how many possibilities we have for each of those 2 items. So 4 times 2 means that there's 8 different ways we could combine those 2 colors. Caleb is filling up a pencil case before school. There are 4 pens and 4 pencils to choose from. How many different ways can Caleb fill the pencil case with 1 of each item? Okay, well, counting principle tells us to multiply 4 times 4, and that would give us 16 different ways he can combine his pens and pencils. If there are 4 types of red apples and 5 types of green apples, how many combinations of 1 green and 1 red apple can you make? Okay, well, counting principle tells us to multiply, so we would say 4 times 5, and that gives us 20 different ways to combine our red and green apples.